Hey, good morning and welcome to this regional climate conference. This is a first for the National Weather Service office here on Guam, and one that we're excited to host. In this day and age of virtual teleconferencing and limited travel across the region, this is something that we wanted to do to reach out across the whole region in one venue to talk about weather, climate, and decision making in response to natural disasters and natural hazards in the region. So again, thank you all for joining us, and I hope this discussion will be beneficial to our weather partners across Micronesia, the compact states, as well as the emergency managers, disaster coordinators across the states and the nations in our region. Communication is key, and it's this partnership that we all have together to protect life and property across the region. So, Leanne, if you can advance to the next slide, we'll talk about the presenters we have today. We have 6 presenters. Brandon Bukunt from our Weather Forecast Office here on Guam, Mike Halpert from the Climate Prediction Center, as well as Matt Rosencrans from the Climate Prediction Center, John Marra from the Climate Center and the Pacific Region Headquarters, Tiare Eastmond from USAID, who will speak about response and preparedness to natural disasters in the region, and myself, Landon, Aydlett, the warning coordination meteorologist here at WFO Guam. I'll be talking to you about our watches, warnings, communications across the Western North Pacific and Micronesia region, as well as provide our collaborative tropical cyclone outlook for the remainder of 2021. So again, thank you once again for attending this conference this morning. I hope this will become an annual thing to bring this all together in this one forum. We will have about 15 to 20 minutes for conferences in the next 2 hours, but if you have any questions for the speakers or the presentations, please write those down or put them in the comment box, the questions box, and Leanne or someone else watching will be responding to those questions. We'll have some extended time after this 2-hour webinar to facilitate discussion. We have my predecessor, Mr. Chip Guard. He's online with us as well. He was part of this collaborative tropical cyclone outlook for the region, as well as Dennis Wang from University of Hawaii Sea Grant, who will also talk about the FSM Homeowners Handbook for Preparedness and Natural Disasters in the region. So we're going to have a lot of opportunity for discussion and questions following this 2-hour period of presentation. So with that, I'm going to hand this over to Mr. Brandon Bukunt from my office to talk about his presentation. So Brandon, the floor is yours.
All right, thank you. Thank you for the introduction and good morning, everybody. Are you able to see the screen here? Title page?
Yeah, we can see it.
All righty. So this is 6/17, but I guess it's a day earlier for those stateside in the U.S. I'll be presenting on the West Pacific drought monitoring and musings, just some thoughts. So overview, just we have a rather broad audience here, so we'll just do a quick background on some of the primary rainfall producing features across the region, pioneering work in the West Pacific with respect to drought monitoring, the new and operational U.S. affiliated Pacific Islands Drought Monitor, a recap of the 2020-2021 drought, a quick look at the new 1991 to 2020 climate normals, mainly looking at rainfall normals for the West Pacific, and then future projections as to where a drought might be going and related material. And the images here, which are courtesy of the Weather Service office in Yap, shows the reservoir during the wet side of El Nino and then the post El Nino drought. So you can see a clear drought occurrence with that year. So given our broad audience, I just want to quickly look at the intertropical convergence zone. You have in the graphic in the upper right, this is just looking at the month of March. but you can see the reds are very high rainfall amounts and largely confined south of 10 degrees north across the FSM, and then you have the RMI and the Republic of Palau to the west, whereas areas north of 10 north are much drier, as you'd expect in our normal dry season. But the intertropical convergence zone is, in a very simplified way, it's largely follows the movement of the sun. So its northward most position is in June, July, and August. And then southward position is December, January, February. And the image on the bottom shows that with the reds denoting a more northward position, and then farther south during the winter months, or boreal winter. So ITCZ is more or less a north to south movement. And then we have interannual variability in the sense of El Nino southern oscillation. You could think of it a sloshing of water across the Pacific region along the equator, with warmer than normal waters towards the Americas during El Nino, and the convection in all this rain that will follow the warm water towards the Americas, whereas La Nina is more of the warmer than normal waters pinned up against Asia and the far west Pacific. So the top panel here shows the El Nino sea surface temperature profile, so warmer than normal waters towards the east near the Americas, and then La Nina, the warmer than normal waters pinned up against the maritime continent of Indonesia, as well as Australia, or Asia. And then you see this large cold tongue of cooler than normal waters along the equator during La Nina. And the red star denotes the location of Kapinga Marangi, and they are actually, they received a exceptional drought this past year due to this La Nina pattern. It's very typical for them to be very dry during La Ninas. And just the photo in the bottom left is from Pohnpei, courtesy of Pacific RISA, just showcasing El Nino is the main player that produces those really bad droughts across the region. So pioneering a work in the West Pacific. 1982 to 83 was a very strong El Nino year, and there was a USGS report by Otto Vanderburg that went across the whole region from the Palau to the RMIs, and really took detailed notes on the impacts that each island group faced. So that was kind of the start of a really scrutinizing drought in our region. And here's a photo from Jalowit. Granted, the pictures are, not what you'd expect to see in this day and age, but it's showing drought damage to coconut trees in Jalowit Atoll in the southern Marshall Islands. And then in 1994, there was the formation of the Pacific ENSO Applications Climate, and that was to serve the US API. It was kind of founded by Chip Gard, and Chip had traveled across Micronesia during the fall of 1997 because he saw the same kind of indications that what occurred in 1982, and that was the high likelihood of extremely bad drought across all of the West Pacific. So he traveled to Micronesia in fall of 97 to warn of impending drought. And this is an excerpt from Mark Lander via email, but in Pohnpei, he had to yell over the sound of pounding rain to urge residents to prepare for drought in the coming months. And you can imagine if you were somebody on the island and you're hearing this as it's torrential rain, it just seems somewhat hard to believe. But sure enough, 1998 post El Nino, it it really did dry up across the region. And interestingly, this is the first time that the FEMA had sent out drought relief in advance. And one of the quotes that Chip more or less made was, send out help now. But if you wait after it happens, keep the aid that you would have sent and just send body bags, highlighting the high degree of confidence in just extreme to exceptional drought across the whole region. And I should also mention that during the 1982 to 83 droughts in the West Pacific, Chip Gar was actually in the Philippines as well, and he did some great work for the Philippines government in hydrometeorological hydro generation of electricity with the dams, and that lower rainfall. He was able to give them excellent guidance to the government over there. So he was involved in the 82, 83 events as well. So looking at some of the tools for drought monitoring in our region, as many of you know, the observation sets are limited. You have little islands in a vast ocean. So some of our satellite-based platforms are rainfall estimate maps from satellites. And you can see here on the left panel, the Marianas are towards the top left. And then you see the large area of rainfall confined to the south. These satellite-derived estimates are very good for deep convection, but sometimes they struggle with shallower trade wind clouds and showers. So that's one caveat to these satellite-based estimates of rainfall. And these maps are available at the link below that. And then on the right is assessing the health of the vegetation by satellite. This is most useful for the larger islands in our region. And the one islands we're looking at here is Saipan. And it's using polar orbiting satellite data to assess the vegetative health. So you can see much lower than normal NDVI % difference from average across southern Saipan, with less drying of vegetation across the central mountains of Saipan. This is kind of highlighting the grasses that are far more susceptible to those drying of vegetation across the periphery, with the mountains retaining a little bit more moisture and greenery. And that's available at the link below there too. And so there's satellite-based, and then there's ground-based. So you have our rain gauges. This is a standard rain gauge here from WFO Guam, but we also have the same instrumentation throughout Micronesia. You also have communication and people. So teamwork. We have weather service offices in Palau, Yap, Chuuk, Pohnpei, and the Marshall Islands in Maduro. Our satellite offices across the region will use Chatty Beetle, which is a form of satellite text messaging, you could say, satellite-based text messaging, or high-frequency radio to go to the more remote islands and get to daily rainfall from, say, Kapinga Marangi in far southern Pohnpei State, or the northern Marshall Islands of Wotje or Wooterik. And the image here in the middle is from Rhoda, I believe, and that's one of our previous employees, Greg Lonian, with crew from Rhoda there. So the people are incredibly important to the whole ability to collect the data, ground-based data, to provide some validity to the satellite measurements, and then what's really happening right there on the island. So let's transition to the U.S. Drought Monitor for the US API. The framework was by Richard Heim at NCEI, Chip Gard, and Mark Lander. It's been operational since 2019, and there's a publication that was in May 2020. And the whole concept was to adapt the mainland-style drought monitoring to tropical islands. And the article, to view far more details regarding the methodology and further details, is available in the article here on the bottom right. But this is the outline of the page on the left image. And this is from one of the more recent ones, June 10th, 2020. And as you might expect, as we head towards more of the typical wet season for the majority of the region, not too much as far as impacts. Just a lingering long-term dryness in Kapinga-Morangi and far southern Pohnpei states, and then the northern Marshalls, the atolls there, having just climatologically a little bit less rainfall. So looking at the framework for the USAPI drought monitor, it's can be simplified into weekly and monthly thresholds. So for the Republic of Palau, Federated States of Micronesia, and the Republic of the Marshall Islands, if the island is receiving 2 inches of rain per week, and I have this here, everything is gravy. It's all good. Everything is green, and you have enough water to meet most needs of the island. The Marianas, with their deeper groundwater supplies, we kind of level that off at 1 inch. So 1 inch per week for the Marianas, and 2 inches per week for the Republic of Palau, FSM, and the RMI. And extending it out to a month, if you get 8 inches per month, everything is gravy. And for the Marianas, 4 inches per month is all good. If rainfall is lower than these thresholds, specifically the weekly, so if rainfall is lower than 2 inches per week for the Republic of Palau, FSM, and RMI, then it's leaning towards things are becoming abnormally dry, and then 1 inch per. And then similarly for the Marianas. And so that's your scale here on the bottom right. No drought, D0 abnormally dry, and then it gets worse if conditions continue. So placing an island in D0 abnormally dry is simply a heads up that say, hey, it's been quite dry the past couple weeks. So that leads us to ask the questions, how is the island doing? How are the water catchment levels? Is there any stress to the vegetation and crops? And then further degradation beyond that D0, abnormally dry, will be determined by rainfall continuing to be below thresholds, and perhaps almost more importantly, impacts. What impacts are the islands facing? And I should also mention that WFO Guam issues drought statements, and this is island-specific details regarding a drought. And this typically is triggered when an island is in a D2 severe drought. And during years of high confidence or areas that are climatologically dry, we certainly can't issue this drought statement in advance because the confidence is high that drought will be developing. So if we were seeing a very strong signal for El Nino, we could be certainly issuing this drought statement well in advance. So just a quick recap on fall 2020 to spring 2021. 2020 focused on a strong transition to La Nina. And mainly there's not too many impacts between 4 degrees north and 10 degrees north, but there was a somewhat classic La Nina drought for Kapingamarangi, which is in far southern Pohnpei state at 1 degree north, roughly. And you can see that the map on the right shows on November 3rd, 2020, virtually the only island with droughts, an exceptional drought at that, was Kapingamarangi there. And the photos below highlight some of the agricultural impacts, drying of taro crop. The breadfruit tree in the center right is, it's hard to see, but all the fruit was inedible or falling off prematurely. And then the banana on the bottom right is completely dried up. And then some of the water that needed to be brought in from the main island of Pohnpei. Oh, and I should also mention that for the rest of the region, it was a fairly normal pattern, with the Northern Marianas and the Northern Marshalls climatologically being on the drier side as well. So, and here's a look at some high-resolution satellite imagery from Saipan on the 22nd of January 2021. So we're looking at the central part of Saipan here, and the photo in the top left is from CNMI EOC, the warning point up there, and it shows a pretty substantial fire. And sure enough, the Sentinel satellite was able to detect that. I have it here in the yellow box on the left, and then a visible style image that is slightly harder to see, but you can see the parched earth and then a trail of smoke bleeding off to the west in the light trade wind flow. So that was a day later, but the satellite was able to capture it. So this is just another supplemental satellite-based tool to assess the condition of the vegetation and fire potential it's very useful for. And just somewhat switching gears here to how to access the new climate normals. The web page is on the bottom here, and they've done some great work in order to make this a little bit more intuitive, NCEI that is. And so simply launching quick access brings you to the next page here, at which point if you scroll down, you can go to Micronesia, Guam, the Marshall Islands, and Palau should be further down. And you can get the latest climate normals, temperature, rainfall, and other variables for the main islands of the region. And I should mention that this data is available in .csv or .pdf format. If you have any questions on trying to access this data, my email will be at the end, and I'm always willing to help anybody out with that. And so just a quick comparison of these, the new climate normals to the previous 30-year period of 1981 to 2010. I should mention, and I should have a note on here, that the climate normals are not designed to look at long-term climate trends, but mainly to look at where we're at now. What can a certain location expect for rainfall or temperatures? And just looking at some quick trends here, this is how things shape up comparing the new 30-year period, 1991 to 2020, with the previous monthly normals in 1981 to 2010. And what the data shows is that there's a good number of the main islands that are actually wetter between 5 degrees north and 9 degrees north. And perhaps I postulate that maybe this is related to a stronger springtime ITCZ pattern across much of the region. And you can see that in the wetter annual rainfall box on the right. Kwajalein, January to May is wetter Madro is wetter from March to May. Pohnpei is wetter February to May. But then there was no clear seasonal trend for Kosrae, Chuuk, or Yap, although these three islands did have annually a wetter profile in the rainfall. So it's hard to say. Far more research needs to be done, but there's some indication perhaps that there is a bit of a stronger ITCZ pattern that's creating a little bit more rainfall during the spring months for Eastern Micronesia. Interestingly, Palau had a drier annual rainfall, and then there was no significant trend for the Marianas, although August to October was wetter for Guam. Rota was wetter during the same period, and Saipan was wetter during August to September. So, in looking at the dry season as well, the Marianas appear to have a trend towards a wetter wet season and a drier dry season. And again, far more research would need to be done as to whether or not this is a true clear trend. But the normals comparing 1981 to 2010 and the new normals 1991 to 2020 suggest that. And one caveat for all of this data is that if you had a big a typhoon in the 2010s, it could skew new monthly rainfall normals up for a certain location. So say Saipan had a 30-inch rainfall event in May. Since it wasn't included in the 1981 to 2010 period, and now will be included in 1991 to 2020, it would skew those new values upwards. So that's just something you need to keep in mind if you see some very drastic differences in the comparing the new normals. And expanding on this a little bit, there's a lot of studies as to where things will go with drought in our region. But if you filter through all the research and just consider the climatology, it's clear that drought will continue, and that arguably the most susceptible islands that are already vulnerable to drought will see the worst impacts. And there's some research by Byrne and Pendergrass and Rapp et al. That the ITCZ has changed a little in location in recent decades, but it has narrowed and intensified. And I wonder if those new climate normals for Eastern Micronesia, mainly Kwajalein, Madro, and Pohnpei, lend some support to this overall thinking of the ITCZ hasn't changed too much in location, but it's become more confined and narrow. And that places islands like the Northern Marshalls in a more susceptible location because climatologically they're dry. But if you have a more narrowing of the ITCZ, it just further enhances this effect. So that's some research by Byrne and Pendergrass, Rapp et al. And then further support for this was a study by the PERCA study by Keener, Marra, Funakane, Spooner, and Smith, that there's a statistical significant drying trend observed across Eastern Micronesia, with some, especially for the Northern Marshall Islands. So there's some support for the new normals that these the papers look at. So just wanted to share that as well. And then just future work and partnerships. I should mention in this first one here, I forgot to mention the Aussies. So the Bureau of Meteorology, Australia, they should be involved in this first bullet point as well. But I'd love to see a stronger collaboration between the various WSOs we have in the region. U.S. Drought Monitor Team, Climate Prediction Center, and the Kiwi at NIWA, and all the other people across the region that make a positive difference. Love to see a boost in the ground-based hydrometeorological observations, surface and groundwater. The image on the right is just from May 2021, but Conservation Society of Pohnpei installed a rain gauge on the highest point of Pohnpei, mainly, I believe, to assess how sediment flows out into the ocean around Pohnpei. The water and the reef is life across these regions, so making sure erosion is monitored carefully and all of the sediment is incredibly important. So I'd love to partner with various people across the region for all of this data that agencies have, so that everybody has the data. It's as we know, it's just a very data sparse region, and the more we get, it can help paint a better picture of where to go. And then just the satellites. There's an immense opportunity and further refining how they can help us improve drought monitoring across the region and prediction, and that should trend into the next talk and what Mike Halpert and Matt Rosencrans will be presenting from the Climate Prediction Center. And there's my email. Please feel free to reach out to me. Any questions, comments, feedback, always happy to hear. Thank you.
Great, thank you, Brandon. So like Brandon said, if you have any questions for him, please put them in the question box and he'll start to look at those questions now as we move on to the presentation from the Climate Prediction Center's Mike Halpert and Matthew Rosencrans.
Turn off my screen. There we go. Well, that's challenging. I hope that you guys are looking at my screens because unfortunately I am not. I'm looking at myself. Anyhow, I will. What's that?
I can't see your slides.
Yeah, Mike, your slides are not shared yet.
I thought they were. All right, let me try it again.
There you go.
Okay. And let me go back to the first slide. There we go. Very good. Sorry about that. And here I thought I was technologically proficient. It must be the late hour here in the States. Yeah, I'm going to spend some time talking about a fairly new to CPC Climate Prediction Center project related to developing new tools for the U.S. affiliated Pacific Islands. Largely, it will be to develop subseasonal and seasonal, so what we call S2S prediction tools. They'll be consistent with the products that we do over the CONUS, Alaska, and Hawaii. So focusing in on week 2, eventually week 3 and week 4, and then monthly out through seasonal. The background, and actually this project was motivated by the work that was done at NCEI to develop the drought monitor. After that became an operational part of the drought monitor, and in particular, CPC probably figured out that there was going to come a point when we would be asked to do a drought outlook. For those that pay attention or don't pay attention to the drought monitor over the CONUS and Alaska and Hawaii, there is a drought outlook that is issued, a seasonal product once a month, as well as a monthly update at the end of the month to that product, to take kind of the starting conditions as to what the drought monitor is saying, and give expectations as to the change in drought over the next month or season. And given the current drought monitor now for the USAPI, it seemed reasonable that at some point we would be asked to do a drought outlook. To do the drought outlook, though, certainly you need to be able to forecast precipitation in particular. Temperature is helpful as well. So we began a project a few years ago to start working with folks in the Pacific region to develop these tools. They're envisioned to be automated, which is currently a little different than what we do over the 50 states. Although I will say that given the improvements to our automated model tools, the manual products that are currently done over the 50 states are rapidly heading actually to be more automated. And so it's very possible that at some time in the future, all of these outlooks for weeks 2, 3, and 4, monthly and seasonal will all be automated. Did get mentioned, I guess Brandon talked a little bit about the USAPI that became operational. He said 2019, somebody had told me 2018. So this is something that we're striving to do. It was also motivated by a pleasant trip that Matt and I took out to Hawaii a few years ago. When speaking with stakeholders out there, this drought outlook was really the product that folks are most interested in, certainly more so than temperature and potentially even precipitation outlooks. Of course, like I said, to get to the point of being able to do a drought outlook, we need to do outlooks on precipitation and temperature on those time scales that would impact it. When we started the project, the initial hope or intent was to do them for the roughly 20 to 23 stations that the USAPI drought monitor is done for. Upon closer examination of the available station data, particularly for precipitation, we ended up kind of focusing in on the 5 stations listed on the map on the left, as well as Pango Pango, which is not shown in this particular presentation. Of course, I'm not sure if the folks that are on this call have interest in that area. What I'm showing here is one of the prototype products. This is a week 2 precipitation forecast. It's done in the same fashion that CPC issues all of its week 2 outlooks. So it's the probability of being in a tercile output. So you have the opportunity to be above normal, near normal, or below normal. What we show on the map is the dominant category. So in this particular case, those areas that are shaded in green, that first shade of green, have a slight tilt towards a wetter than average week ahead. Those areas that are shaded in yellow for this particular forecast were favored to be on the drier side of things. We did look at some historical data, and again, given that it's an automated product, we were able to generate some level of older forecasts to see how well they did. And that's what the figure on the right shows. This is a case where any skillful forecast is above 0. Of course, just because it's above 0 doesn't mean that it's a useful forecast. Obviously, the greater above 0 the forecast is, the more skillful it is. This is what's called a Heidecke skill score. And again, it basically measures the improvement over of a climatological or a random forecast. In this case, most of the verifications, and they're broken down by years, are for, and with the thing labeled as a 1 is the mean of the 2.5-year period. 2 is the verification for 2018, 3 is the verification for 19, and then 4 is the first half of 2020. But really the takeaway from the figure is that in general, the forecasts verify between the 10 and 20 range. And the reality is that's actually fairly close to the skill of the forecasts that we issue in a general sense over the 50 states. So on a bright side, the skill of these forecasts there is some skill there. I mean, certainly not as high as we would like, and we'll talk a little bit more as to ways that we're going to try and improve those forecasts. Before we get to that, we are also looking at issuing or developing monthly and seasonal outlooks. Again, this figure here shows an example of a seasonal outlook it's from August, September, and October. Would have been issued in July of 2020. Colors are a little different, but the message is still the same. The areas that are in brown are favored to be drier than average. Areas shaded in green favored to be above average. Here's a case where areas favored in gray are actually favored to be near average. This is from the North American Multi-Model Ensemble. So again, it's another automated tool. And I'm touching on the tools here. When Matt does his presentation, he'll provide more information as to how these forecasts are actually generated and what goes into them. We have a similar type of an outlook for the monthly forecast as well. Looking at skill for these, and again, it's the same 6 stations that we've kind of settled on to begin. Shows that the skill, again, in a general sense, you know, maybe well, somewhat comparable, depending on the station. On the bright side, Guam is actually the best skill, at least over this, and this is now actually over a 25 or 30 year period. So it's of course there's one season, one winter, one season per year. The verification, again, for those not familiar with our Weather Service terminology, JFM is January, February, March, FMA, February, March, April. Across the bottom, you get to December, January, and February, DJF, and then the mean is the average of the 12 overlapping seasons. You can see some of the stations are better than others, certainly. Some of those, in particular, I guess it's Ponape and looks like Chuk, are virtually skillless, shall we say. I mean, pretty close to zero, but again, some of the stations do have some skill. Guam's not too bad, Kwajalein's not too bad. And there's a lot of variability. And one of the things that we didn't focus on in this particular presentation here was the seasonality of rainfall. Certainly it's probably more important to issue skillful forecasts during the rainy season than it is during the dry season. Looking at the monthly forecast, it's again a similar type of a picture. You know, a lot of variability. Some stations are better during certain seasons. If you look over on the far right, you'll see the means, and again, generally between 0 and about 15. Actually, a lot of them kind of bundle between 10 and 15. Again, that's for a monthly forecast. That's actually, again, pretty close to what we typically get over the CONUS, but there is certainly a lot of variability in that. So that's kind of was the first cut. We are exploring ways to take the raw or the calibrated model output and downscale it. We've had some success doing that through our international desks. Matt will talk a little bit more about that. If we're able to do that, the forecast would likely then would go from the presentation of a map form like this to a particular point forecast, say for Guam, with some probability of being above that could in theory be somewhat different than you would pull off of the map itself. But that's still exploratory. Again, this whole project has been only underway a couple of years. These are some of the upcoming activities. Talk about things in terms of fiscal years, but we're more than halfway through this year, and some of the things we're doing, that IRFCON, which is the basis for the week 2 forecast, was upgraded to a more skillful version of a computer model that's run here at NCEP. But we haven't had an opportunity yet to verify or to see whether those forecasts are actually improved. Certainly the hope is that they will be. Again, we're talking about downscaling, and then the kind of the rest of this year will be devoted to adding similar type products for temperature, again, across time scales, week 2, monthly, and seasonal. That is to generate and then verify, and then longer term. And one thing that we've omitted at this point right now that we will start on later on this year are week 3 and week 4 outlooks. We've kind of paused on those. The original intent was to do them this year. I'm not sure if this audience is familiar with our week 3 and week 4 outlooks, but we've been issuing those since 2015 in an experimental mode, although temperature became operational in 2017. But they're a 2-class system. So whereas our other outlooks, the week 2, monthly, and seasonal, are tilted towards above, near, or below average. The week 3 and week 4 so far have been a 2-class, so it's basically either above or below average. The plan next year is to convert those to a 3-class, and as we're doing that work to do that conversion, it seemed the appropriate time to work on the 3-class outlook for the U.S. affiliated Pacific Islands. The following year is when we notionally would like to develop that drought outlook. It will be somewhat dependent certainly on the skill level of the temperature and precipitation outlooks, but we're fairly optimistic that they'll be skillful enough that we'll be able to issue a drought outlook. And again, we think that's the product that folks are really looking forward to. And then even looking further down, potential exists for some type of a wind product. Matt will show actually some preliminary work on a wind tool that links to our hazards outlook that does cover week 2 right now. And then even longer term, some sea level height, since that's certainly another critical element that can have significant concerns for the islands out there. And I believe I will continue to show slides for Matt. Just tell me when, Matt.
Go ahead, next slide. All right, so Mike talks about the week 2 product. I kind of broke this down as far as our products that look at total precipitation or mean temperature over a week or a 2-week period, whatever base period is. So one of the things that Mike talked about before was what we call our ERFCON, our extended range forecast consolidation. That would form the basis for the week 2 outlook. It would be currently set up as the JEFS and the ECMWF, both of those models going into it. They would both be bias corrected and calibrated using their hindcast for the bias correction and using the observations at the islands for calibration. So it's a multi-model consolidation. We are working also to include Environment Canada, their modeling system in it, but obviously we would test all the components. If we add the Canadian model to it and it's not as skillful, then maybe we wouldn't put the Canadian there. If we would put the Canadian in there but use some of the calibration methods and it removes some of the members or it's got a different bias, then that's okay too, and we could still include it. We do have a few other projects in the works that are we are working to use machine learning or artificial intelligence based. I know those those are used interchangeably, but they're not technically the same thing. But so it should be really machine learning based models, combination. So that's one project that we got some funding for earlier this year. We're just working out the details of how to execute that compute time to basically put multiple models into a machine learning algorithm to then train and create forecasts for the US API for the islands that we have the good training data for. Next slide. This is an example of kind of the process that happens. I know we've gotten a lot of questions on this. So what happens is you take the reforecast from all the past years. This is based off of the GEFS 10. We've gone to GEFS 12. So we have to go back to 1989 through 2019, not 1985, because the new hindcast is a little bit further in period. But you figure out the relationship between the reforecast at that time and the observations. That creates your bias corrections for your ensemble mean. You apply that same bias correction to all of the members for the current real-time forecast, and then you normalize their distributions. So that way, if there's 31 forecasts, you take 1 over 31 and add up all of their forecasts that way. Then you get to your value-added product from that's any single model. Then you can, so that becomes in your bottom left, your value-added product. Then you look at the last 45, you take all those current real-time value-added product from any model that you can create it off of, and then look at how that did in the last 45 days of this year, or plus minus 45 calendar days from the same date of last year. Score that versus those observations, and that becomes your weight. Apply that weight to the value-added product, and that becomes your consolidated probability outlook for the day. So if we can get a hindcast, we can do, and the real-time forecast, we can do this for any modeling system we wanted to. Next slide. So that's for week 2. We don't have a week 3 and 4 multi-model that is global yet. We have some combinations that are over North America, but we don't have them global yet. So I haven't mentioned those. Those will be in the development section later. The premier product for the monthly and seasonal outlooks would be the NME, the North American Multi-Model Ensemble. That would be the premier product for CPC. There is also an international multi-model ensemble, which has been replaced by the Copernicus Climate Change System, C3S. So we're undergoing some evaluation for that, but those models have very differing hindcast periods, each one of those. So it's a little bit harder to do a direct comparison. But the North American Multi-Model Ensemble, you can see here, it has the CFS, two models from Canada, 20 members from GFDL, actually 30 members from GFDL, 10 members from NCAR, and another 10 members from NASA. So all those members are brought in, so it's 10, 20, so it's 32, 60, 70, 80, 90, almost, so about 100 members, 100 models are run every month, and those are brought into both create averages and probabilities. If we were to do a spatial subset around the Western Pacific, this map is for the US API, but we could do it for West Pacific up around Guam, basically any lat-long box. We could create a specific image for that area. Next slide. So that's basically what one of the project is. It's both 2 parts. Creating custom plots for the different area. We already do this from the CFS, on the sample there shows North America, Arctic, Europe. We do that for just the CFS. We could expand that and do that for the entire NME. We could also create, instead of just averaging all of the NME models, some of the research shows that over subdomains, not over the globe, a multi-model average works the best. That is your path of least regret. That'll minimize all your errors. But over any given subspatial area, that's not necessarily true. Some models are better parameterizations that handle ice fluxes better. Some have better parameterizations that handle ocean fluxes better. Some have a higher resolution when they're run. So they have a better representation of terrain, so they may capture island terrain a little better. So figuring out a combination of models to optimize the skill over the area around Guam or over the US API or over Hawaii, that can be a separate task that we're going down to. So regional combinations. That would mean you couldn't stitch them back together and make a global plot out of that, but regionally you could do that. Downscaling also to the points. So taking the model grids, all the grid points, plucking out grid points or creating area averages and then building a relationship to the observation at that point. Doing that over the history of the model, that's another way. We are working with the CPC International Desk and the IRI to use some of their software packages to do this. Next slide. I think I get into more details on those later. Yeah, so so basically this plot here, the spatial loadings on the left, that is the spatial loadings from a precipitation forecast from NME. So you take that area right there, you load in the precipitation. It'll find the first or second modes that control most of the variance. You can do 3 or 4 modes, you can retain them. Then you actually find out the spatial loadings from when you apply those to the same to correct the variance and correct the observations at the points, or to correct the precipitation values at the points over the islands. So it allows you to create a relationship between the spatial field and the points, and so the spatial history of the spatial fields and the history of the points of the precipitation at each one of the islands. Then when you get a new forecast, you have this spatial field from the models, you can then apply that relationship and come up with a better forecast of each one of the islands. We are working on scoring this method here with running it through the same scoring code that we get when we just take the NME model point that is directly above each island and scoring that. So if the NME was to make a direct forecast for the island, we have scored that already. Now we're going to send the NME inputs through a post-processing method and then build a relationship for the points. Then score the output from the NME passed through that calibration relationship. Next slide. Some of the predictors that we have tested are sea surface temperatures in April. This was to make June, July, August forecasts. So to make a June, July, August forecast, we've tested sea surface temperatures from April. We've tested tropical Pacific sea surface temperatures. You can see the different areas, the bounding boxes there. We've tested the tropical Pacific SST is a different source of data. You can see it's the same spatial area as the ERSST, but it's the tropical Pacific SST from the NME model. It's not from the observed. We've tested tropical Pacific precipitation from the model from JJA. What did it predict over that spatial domain? We also tried to subset it to just the Western Pacific, so 5 south to 20 north, rather than using the entire tropical Pacific. We've also tried just taking the NME point that is over top of the island. So you can see, depending on which station you're looking at, some of the different parameters from the models perform differently when you then feed them into this CCA method to then create these forecasts for your islands. So we'd have to create multiple layers before we could automate this. We'd have to extract the model field for each one of these fields, create that index, and then do that forecast for each one of the islands. But then we could, as Mike said, we could stitch it all back together to make a singular map. Next slide. So those are the products that we'll talk about, kind of means and totals. We do have some other products that address some relative extremes, such as high precipitation, high winds, sometimes even low wind events. Next slide. So one of the things we do that's model-based is we use that GEFS calibrated method to produce probabilities. And this is an example of a map that's centered around Guam that shows the probability of exceeding the 85th percentile. So in that darker outline there is a 20% contour. So you have a 20% chance of exceeding the 85th percentile. So you have a 5% chance, increased chance. I do see the question, and I'll get back to the question at the end. You can also invert this calculation and see, I can't do it now because it's not a live demonstration. We can add the probability of exceeding 1 inch, 2 inch, or 4 inches in a single week. or excuse me, in a single 3-day period. Then there's multiple day periods, days 8 through 10 to the future, 10 to 14, or 12 to 14. So that kind of takes us through week 2. But week 2 broken down into 3-day chunks. So and the odds of exceeding like 2 inches between this, odds of exceeding 2 inches on days 10 to 12. And you can cycle through any combination of those. So one question I would have for this group here is, what other thresholds could we add? So we have 1 inch, 2 inches, and 4 inches in any 3-day period. So those are kind of what we've been using for a while. So just think about what other thresholds we might add. Next slide. That same tool, so this is just examples of when you can show the probability of being above the 85th percentile. That's on the left-hand side. But when you look at the probability of exceeding 2 inches, it's kind of a rainy part of the world. When I pulled out some of these outlooks, so your odds of exceeding 2 inches can be 20 or 30%. But when you look at it on the left, that 2 inches may not be that far above climatology. Maybe not be too different than climatology, so it doesn't register because it's not the 85th percentile. Whereas if you now look on the right-hand side further to the north, where climatologies can be lower, you're not getting 2 inches. Maybe you're only getting 3/4 of an inch, but according to the plot on the left, that means 3/4 of an inch is greater than the 85th percentile of the historical distribution. So there's 2 ways to kind of slice and dice this data. Next slide. You can also do for temperature. That's on the left-hand side there. Maximum temperature, minimum temperature. There's lots of thresholds on there. I thought I put the link. No, the link's in the first slide. So after this presentation, you can grab the link and play with that website. Give us feedback on what thresholds matter more. For maximum temperature, minimum temperature, and winds. Winds, the forecast is still the 85th percentile, but also 25, 45, and 50 miles per hour. We don't have a low wind forecast map on here yet, but that's something we were asked to develop when Mike and I went out to Hawaii. Next slide. We're also looking at doing, right now we currently do a week 1 and week 2 tropical cyclone outlook. Multiple models go into this. The GEFs, CFS, ECNWF, and Canadian all go into this. JMA does as well, but indirectly through its indication of the Madden-Julian oscillation. Partnerships, JTWC, Taiwan Central Weather Bureau, JMA, Navy, and the Bureau of Met from Australia. They're all actively involved in this product as routine collaborators. And then we have intermittent collaborators, such as monsoon season, India Met Department. We'll get feedback from them overnight. Depends. Sometimes for our international desk at CPC, we integrate their products into this, and then sometimes they get feedback from their partners in Africa, and that feedback will come back into this map. I will say that we're likely shifting this product from a week 1 and 2 outlook to a week 2 and 3 outlook. So it would still be above normal and below normal precipitation, but those would be probabilistic, and it'll still be areas where we think tropical cyclones are likely to form in week 2 and week 3. Most RSMCs, RSMC Tokyo, and Fiji, most of them are doing outlooks through week 1. JTWC is even they're doing a multiple day outlook that covers most of week 1. So we want to be able to get out of that and go to week 2 and 3. So that's why we're trying to make that change. Next slide. This is kind of some of the tools that are going to be behind it. Again, it's CFS, GEFS version 12, ECMWF, and Canada. Their ensemble prediction system. We got all the hindcasts. We run tropical cyclone algorithms, tracking algorithms, figure out density plots, figure out false alarm rates, and then you take your current model output, mask out your high false alarm areas, and see if there's any tracks that are left. And then that's where you can potentially highlight a tropical cyclone formation area. Next slide. Weeks 3 and 4 outlook as far as precipitation. There's still a lot of work to do there. Like I said, we have model tools, but we don't have anything more than a multi-model ensemble for weeks 3 and 4 that is global. And we know from the CONUS and from North America that the models aren't great in this week 3 and 4 period, and you need a lot of statistical corrections, and you need a lot of statistical tools on them. So that's why it's still a growing area for this. There are the model pages. The SubX page is listed in here, so you can look at that. We are working on doing different sub-regions of the world off of this multi-model ensemble data. But again, it's just when you're looking at week 3 and 4 model data, broad fields of it, just be cognizant that the skill is quite low. Next slide. So I know Mike and I have talked. I asked for some questions and some, what thresholds and things like that would be useful. And then we wanted to get some time for, I don't know if we have time for stakeholder output, but I do know I want to answer the one question. I don't know how to read the whole question.
So Matt, before you keep going, I think what we had decided was that we would go kind of through the 6 presentations and try to have the discussion at the end. So while I have these couple of thoughts are on the screen, these are things that Matt and I would like to get some feedback and take something away from this meeting as to folks think about kind of images that we've presented a little bit. I do see a couple of questions in the question box, and I guess I can try and take them quick. I think both of the questions relate to the fact that in the products I showed for week 2 in particular, we were focused on 6 stations, and the question kind of then links to what about the other stations, the other islands out there. Certainly the model forecast that I showed would overlay all of the islands, so you'd be able to see the forecast. The challenge that we found was that the station data, at least for precipitation at the other islands, wasn't very complete. So it made it pretty much impossible to determine the tercile limits to determine whether or not the model forecasts were very good or not. So that's the presentation of the 6 stations really focused on the verification as to how good those were, and it doesn't mean that the maps that we're showing, they certainly will obviously include all that, but not having the high quality complete station data makes it difficult to verify, and it will likely make it difficult to do any downscaling as well.
Yeah, it was tough when we were going through a lot of the data. We went to NCEI because having worked through the data with Richard Heim, when they set up the USAPI drought monitor, all the stations that were on there, that was our initial goal, was to replicate those same stations. We pulled all of the data that Richard Heim told us to pull for those stations, and it didn't, and a lot of those stations had a lot of holes in the data. So I see PR Rock saying you should be able to download them. Oh, is that for the slides or the data?
Oh yeah, sorry, that was for the slides.
Okay.
Yeah.
I'm like, we should be able to download data. Like, where's the data? Because if we can get the data, we can run the analysis. But we had a lot of holes in the data. Some of the stations had, they would have, in the 30-year record, 4 or 5 years missing. They would have multiple times a year where there was sections of the year missing. So getting the precipitation observations in and really sent in on a routine basis is critical. If you have back observations, you have stacks of forms somewhere with them, from 1997, the precipitation, scan them, email them. We got to figure out how to get them into the NCEI GHCM database.
And I guess the other comment, and it was from Chip, about using monthly data, and I guess we kind of went through the daily stuff. Just thinking about it now. To verify the monthly and seasonal, if there is seasonal data that's complete or monthly data, I guess we could expand that, although I would hope that there's not a lot of missing days that go into the monthly and seasonal data. I mean, obviously you can grossly underestimate precipitation totals if you're missing data on the days that it rains, basically. So, you know, it makes it a little challenging to know what you really got. That's why we really wanted to work with the daily observations, because that way we knew what was complete and what wasn't.
So I don't see any more questions in the Q&A box.
No, I guess, and I don't know, Lee, do you want to?
Yeah, all right. So we'll conclude your section there, Mike and Matt. And if anyone has any other questions for them, please put it in the question and answer box. And then at the end of everyone's presentations, we can go through some more of the questions that were posted or try to do a raise your hand section. But now we will turn it over to John Marra, and he'll be covering climate change in the Pacific Islands.
Yeah, thanks. I think, Leanne, I think you're going to cue up the slides. There we go. Beautiful.
Yep,
Thank you very much.
I believe everyone should see them now.
I can, so I hope everybody can hear me. So thanks for the opportunity to talk to you guys. You can go to the next slide. I'm going to change the subject a little bit. We've been talking basically about, next slide. Thanks. So we've been talking about climate variability, the noise, if you like, you know, ENSO, MJO, seasonal patterns, PDO. I'm going to shift and talk a little bit about some of the signal, the trend, the longer term change that's primarily a result of anthropogenic forcing. And so changes that we're talking about happening over years to decades, as opposed to some of the shorter term patterns that we've been talking about so far. Next slide. So it's really all about CO2, carbon dioxide in the atmosphere is increasing. This is just a picture from the CO2 being measured at Mauna Loa. Can't tell exactly there, but we're at almost 420 right now. That's about half again what it was at the beginning of the industrial, pre-industrial conditions. It's the highest level that it's been at in you can go to the next slide. It's not just high recently, but when you look back on the record, it's about the highest level that we've seen, and this only goes back to 800,000 years, but it's the highest level that we've seen in about 4.5 million years. So it's the highest it's been really since anything resembling a human being was on the planet. It's interesting to note at the rate we're going at, it'll probably be about double that background rate. So it'll approach 560 within a lifetime of people that are on this call. Last time it was at that level was somewhere around the Eocene Oligocene boundary, which was about 30 to 40 million years ago, and the Antarctic was tropical. So you can go to the next slide. It isn't just CO2, it's other greenhouse gases, and this is just another measure that they take at Mauna Loa of looking at things like methane and chlorofluorocarbons, and just gives you some sense of what contribution is CO2 relative to the other greenhouse gases that are being concentrated in the atmosphere. And again, it's the same sort of thing. We're seeing this hasn't been being measured as long, but you're seeing it increasing and increasingly increasing. Thanks. Next slide. So when you start to pump CO2 in the atmosphere, you start to enhance the greenhouse effect and increase surface air temperatures. This is a clip of sort of aggregated, if you like, surface air temperatures for the region defined as Oceania by NCEI. I don't know exactly what their bounds are. I should know that. But you can see sort of the transition from blue to red, showing a solidly increasing trend of surface air temperatures. Just FYI, 2020 was the 4th warmest year on record. It was about almost 2 degrees Fahrenheit above the average temperature. I'm just looking at a couple notes here. So the 1990 to 2020 trend was about 20 degrees Fahrenheit. And if you look at the more recent trend, so starting in say in the 80s, is actually closer to 0.4 degrees Fahrenheit per decade. Next slide. I just note that while this was our 4th warmest year on record, it was actually the 2nd warmest year on record for the globe. And take note that it was a cool year and that it was a La Nina year. This is just show rather than the sort of Oceania. I just pulled this is a record readily available through the NCEI webpage, and it just shows the trend at the Honolulu Airport Station since 1941. And notice that in this case, it's 0.1 degree Fahrenheit per decade. Next slide. I'm going to try to move through stuff really pretty quickly to kind of catch up on our time here. This is just another variation on how you can look at trends. Some of you guys may be seeing these warming stripes. This is the warming stripes for the Marshall Islands from 1909 to 2019. And again, the sort of blue to red transition showing the increased temperatures. Next slide. It isn't just mean, the way it's important to think about it, how you see it isn't just necessarily mean temperature. These are actually the number of days with temperatures above the, so basically think warm highs and lows. So warmer days, and that's what you're seeing for Majuro. So an increase in higher temperatures. And then you're seeing a decrease in cool nights, so in lower temperatures. And that's one that warmer nights is a trend that's very distinct across particularly the Pacific. Next slide. So if you're adding CO2 and you're warming up the air, you're also warming up the ocean, so it's expanding, and you're melting ice, and so it's adding to the ocean. So as a result, the sea level is rising. This is an image that Matt Woodlansky put together over at the University of Hawaii Sea Level Center. What you're looking at in the background shading is the sea level trend as observed in the satellite altimetry starting in the period 1993. And so you can see in general there's sort of a 10 to maybe not quite 20, but sort of a we'll say 8 to 15 degree cumulative increase in sea level rise. The little dots on the map are the tide gauge locations. In this instance, you'll see that the tide gauge locations in some cases are different than the satellite altimetry trend, and that has to do with local variations that aren't picked up, like changes in vertical land motion, other sorts of factors that affect the rates locally. We'll see that in the next slide. And this is just a clip for the tide gauge location at Malakal and Palau. And you can, again, you see the distinct trend, but you notice that there's a slight difference between the altimetry and the tide gauge. I'm not sure exactly what the reason is for it, but it's just to point out that the idea that we have these two main observing systems. They aren't always in sync, but they both provide valuable information. Globally, we've been looking at a rise of around 20 centimeters since 1880. The rates that we're looking at right now, I think it's since 93, it's been about 3-4 millimeters a year. If you can go to the next slide. If we keep projecting this out, even under the current rates, these are just other versions of these sea level trends. This is the Co-op's website. This is again over in Kwajalein, going back to the 40s. If you project these trends out, even at the current rates, we're looking at least another foot of sea level by 2100, and a lot of estimates suggest we have some acceleration that point towards an estimate of about 3 feet being reasonable by 2100. One more slide. And this is the gauge over in Samoa. I put it in here to illustrate a couple things with respect to sea level. Steady trend, and then boom, there's an earthquake that happened and it knocks everything off kilter. And so one of the things when you look at the sea level trend in Samoa, you're going to see some sort of weird things going on. It looks like very rapid acceleration, and most of that's actually due to vertical land motion. Okay, next slide. So we pump CO2 into the atmosphere, but we're also pumping it into the ocean. And this is a image from, it's actually the folks that over at Station Aloha, which is a measurement platform offshore from Hawaii, Oahu specifically. And you can see on the top is the atmospheric concentration that we saw earlier of CO2 at Mauna Loa. And on the blue is the concentration of CO2 in the seawater, just showing a sort of a similar increase. Next slide. What you're seeing now is instead of measuring CO2, you're looking at acidity, essentially pH, and so you're seeing increasing acidification, a trend of increasing acidification over time. And there's, again, there's a lot of noise in almost everything I've been showing, but, while there is noise, there is also a signal that exists within it. Next slide. Last couple here is, so other things that we're seeing changing that are a little less clear. It's much harder to know exactly what's going on with things like rainfall and storminess. There have been a couple recent papers that kind of look at different flavors, if you like, of the El Nino Southern Oscillation. Here's one suggesting that the typical Eastern Pacific or kind of canonical El Ninos, like the 82, 83 kind of event, are actually decreasing relative to these Central Pacific events. I kind of think of them as El Ninos that stall. And so there seems to be an increasing frequency of those, at least in the last 20, 40 years. Whether or not that's going to continue to increase is not clear. Next slide. Just another paper showing a similar sort of result. In this case, it's based, I think, on some coring in coral records, and it goes back further. But what you're seeing here is not completely clear, but the axis is essentially the ratio of Central Pacific versus Eastern Pacific events, and it's showing that in the end there's this, not that it hasn't happened, there haven't been variations on it in the past where it's appeared to have occurred, there have been some oscillation in this, but there's a very distinct change in the last couple of decades. So next slide. So what happens when you, all these things I just talked about that are shown on the left, you're ramping up carbon dioxide, increasing air temperature, sea surface temperature. I skipped sea surface temperature, I guess I should have mentioned that. That's a big deal. I forgot all the, just noticing it now as I prepared the slide deck. But all these forcings lead to societal impacts. So things like decreasing freshwater availability is already an issue. It's likely to become more of a concern with rising sea levels. Even if we don't get more intense or more frequent storms, we're still going to see increased flood frequency just as the tides begin to slowly creep up. We're seeing, particularly in the context of sea surface temperatures, we're seeing warmer oceans, which are going to be bleaching corals, changing locations of fisheries. And when you combine that with acidification, there's significant stress on marine ecosystems and even the food chain. And what all those end up doing is creating threats to both lives and livelihoods of the folks and the people that are in the Pacific. Impacts to food and water security, as well as just general health and safety. So the takeaway, I think, is on the sort of long-term trends is fasten your seatbelt. Things are ramping up, and it's a rapid change, and it's getting rapider. And when you add the noise to the picture, it's going to be a bumpy ride. Thanks.
All right, thank you, John. So if you have any questions for John, you can put them in the question box or wait until the end. We can do a little bit of live question and answer. On the screen now, you should see his email and then a few key websites for NCEI and some more information there. So now we'll pass it over to Landon, and he's gonna round us out. Let me just get his presentation loaded. 1 sec.
Yeah, thank you again for joining us today. We're going to have a little change in programming here. Tiare is out away from the computer right now to handle a situation. She'll be joining us shortly, hopefully, while I'm presenting, and then she'll give her presentation after me. So I'm going to run through my slides right quick, and I see it up on the screen. So thank you, Leanne, for running this. I crashed out of this system a little while ago, so if I go silent or lose the feed, I'll have to join in on another computer as attendee, and it'll be without camera. So Leanne, thank you for running things on your end, and let's go on. We're going to be talking about the National Weather Service Guam, our communications for tropical cyclone warnings and watches, and then also where to find that information, and then finish this presentation with the outlook for the season or the remainder of 2021 for the Marshall Islands, Micronesia, Palau, and the Mariana Islands. So if you have any questions, type those in the windows. Otherwise, the presentation is attached as PDF, and we can talk following this meeting, and I'll have my contact information following this presentation. So next slide, Leanne. So the WFO Guam, we have a very large area of responsibility that encompasses much of the Western Pacific, and we have forecasting authority over the Republic of Palau, the Federated States of Micronesia, and the Marshall Islands. We work closely with the Weather Service offices on all of these main islands to disseminate weather forecasts, watches, warnings, and advisories for all of the islands. The WSOs, they take our information and then transmit that and coordinate that within their islands, their states, their nations, with the disaster coordinators, emergency managers, so that we have one consolidated, concise message, and it's translated and disseminated to everyone, as many people in the islands. Next slide. WFO Guam, we do have 39 warning points across the region. And so these are all the warning points. If there's a tropical cyclone threatening any of these 39 points, we go into a full watch and warning mode for tropical depressions, tropical storms, and typhoons. So you can see all those islands listed there for both or all of the Palau, the Mariana Islands, Micronesia, and the Marshall Islands. And again, we go into a full operations mode for watches and warnings for any threats that affects these islands. Next slide. Now, what are those watches and warnings based on? When do we issue those? Well, the damaging winds, those are based on 39-mile-per-hour winds. You can go ahead and click through this, Leanne. Our watches and warnings are based on the onset of those 39-mile-per-hour winds, and they're averaged over a 1-minute period. Destructive winds are at 58 miles per hour or more. But our tropical storm watches, our typhoon watches, and our warnings, they're based on when those winds are set to move in, because we want all preparedness actions and activities to be complete before those damaging winds of 39 miles per hour or more are set to begin at any of these 39 warning points. So tropical storm watch, that's when those winds are possible from a tropical storm or developing tropical storm within 48 hours. A typhoon watch is based on a typhoon or a developing typhoon posing a possible threat, and that's with those damaging winds set to arrive within 48 hours. The warning, that's based when those damaging winds are expected within 24 hours from a tropical storm or a typhoon that's going to be setting in near a location. Next slide. This chart basically shows those watches and warnings in an easier to view format. Again, the watches and warnings, those are based when those tropical storm force or damaging winds are possible within 48 hours. Plenty of time to get ready and get your community ready and prepared for a possible storm or typhoon. The warnings, those are when those damaging winds are expected to begin within 24 hours. And so the key thing to note, watches and warnings are based on the onset of damaging winds. Next slide. So when I talk about WFO Guam and our bulletins, we have a full suite of tropical cyclone bulletins that get activated for any island that's under a threat, whether that island has 10 people or 10,000 people. We go into a full operations watch and warning mode to protect that life and property. This is all generated once that the Joint Typhoon Warning Center has issued their first warning for a tropical depression that's developing into something more formidable for an island. So the Joint Typhoon Warning Center, they put out their warnings every 6 hours at 1 and 7 a.m. and p.m. Tomorrow Standard Time. That queues up our processes for the public advisories. Our intermediate advisories go out every 6 hours at 2 and 8 a.m. p.m. Tomorrow Standard Time. And then if there's a watch or warning issued for any of those 39 warning points, we issue intermediate public advisories to keep more updated information flowing to the public. So basically every 3 hours, we have information coming out through public advisories for an island that's under a watch or warning. And you can read through this following this presentation. The local statements, this is a very long text bulletin that we issue following the public advisories at the 3s and 9s tomorrow Standard Time, providing that detailed localized information. What kind of rain totals are we looking at? What's our estimate for rainfall, flash flood potential, mudslide potential for the mountainous islands across the region? Also, seas and surf information, as well as a recap of that storm information, whether it's a tropical storm, a typhoon, and that's related to our public advisories. The local statements is where you want to be if you want to get that detailed information for individual islands. Whether you're in Micronesia, the Marshall Islands, or in Palau, this is where that information is. Tropical cyclone updates, we issue this hourly when there's a tropical system within about 230 miles of Guam. That's when it's within our radar range, and we can start getting more detailed information on that inner core of the storm and provide those tracking details. Next slide. So the webpage, this is where you want to find all of those bulletins. You go to our homepage, weather.gov/GUM, and you see the red box up top. That's our national web links. But if you go in the green box and you hover over any of those links, that's where you get the localized forecast, our zone forecast for the Mariana Islands, coastal waters forecast for Micronesia. And then this map in the larger box in the middle, that's clickable for the Mariana Islands. You click on the island and you get your detailed island forecasts as well as these conditions. Now hover over the current advisories in the box on the right-hand side. Click on tropical cyclones. That takes you to our tropical cyclones page. And as you can see in this example, there are no active tropical cyclones at this time. That's as of yesterday afternoon. If we have a tropical system that's being warned on by Joint Typhoon Warning Center, we're going to have bulletins up there, track and intensity forecasts, graphics, as well as the public advisory. That information that's available will dramatically increase if there's a watch or warning for any island in our region. There's 39 warning points. So this is where you want to go to find the latest information. We will be posting this information on our social media pages as well, Facebook and Twitter. But for the latest, most up-to-date, go to our tropical cyclones page here on the screen, because that's where we're going to have things routinely updated every hour or every 3 hours accordingly to that information that's being provided. So the next slide, we're going to transition into our seasonal outlook now. As many people know, and Chip Gard has done a mighty fine job over the years through workshops and training events across the islands, talking about tropical cyclones, their typical activity across the region, how they move across the region, and how closely tied they are to the current state of the climate. And for us, that would be the La Nina pattern, the El Nino pattern. We had a very slow tropical cyclone year last year, and that was in response to a moderate to strong La Nina that kept a lot of the activity suppressed across central eastern Micronesia, as well as the Marshall Islands and Guam and CNMI. Most of that action was occurring in the Philippine Sea well west of our area, with the only threat for us in the region was a tropical storm Atsani, which moved past Guam on October 30th. We've had a little bit more action this year. We have transitioned to a INSO-neutral pattern, which means we're going to be looking at more of a near normal pattern for tropical cyclones across this region. The next slide. This shows the breakdown of numbers with what we expect of the possibility for tropical weather across the region. And so we have to put it in this chart because its activity will vary significantly from east to west and north to south. And again, this is primarily an outlook. This is not a certain forecast of this is what's going to happen. This is an outlook for the possible tropical cyclone activity across the region for the remainder of 2021 based on the current INSO neutral pattern. So it's going to be, we expect it to be a busier tropical cyclone year for 2021 than what we had in 2020. And again, that's based closely to the climate pattern. And the columns on the right, the tropical storms and the typhoons, those are combined. So for the Marshall Islands north of 6 North, it's possible to see 1 to 2 tropical storms, but then an additional no or 1 typhoons. So for the Mariana Islands, for Guam, Rototini, and Saipan near the bottom, we could see roughly 4 to 6 tropical cyclones in the Marianas region, with 2 to 3 of those being tropical storms and 2 to 3 of those being typhoons. So keep that in mind. We will see a little bit more activity across the region in the coming months. Our peak season for the Mariana Islands is typically August, September, October, and similar months for the rest of the region. And again, the activity varies from east to west and north to south. So the next slide, Leon. Some of the key notes from this outlook, you have to keep in mind that we are expecting near normal activity, and that's consistent with INSO neutral conditions. This outlook does indicate a busier year than what we saw in 2020 during the La Nina event. The tropical cyclone activity varies considerably from east to west and from north to south, and it's a general guide of the predicted overall tropical cyclone activity across Micronesia. It is not a prediction of how many systems will actually make landfall. While the activity can fluctuate year to year, tropical cyclones can and do occur anytime throughout the year. We already had tropical storm become Typhoon Surigay. It was a very powerful super typhoon just east of the Philippines. That was back in April. And in previous years, think back to 2015, that was a strong El Nino year where we had tropical cyclones well early in the year. That was Tropical Storm Bobby through the Mariana Islands in March, Typhoon Dolphin in May, Chanhome in July. In 2019, we also had Super Typhoon Wutip, which developed in Chuuk and Yap states and passed southwest of Guam. That was a February super typhoon. So keep in mind, we have the possibility of tropical cyclones anytime around the year, and that's why people across the region should maintain a general state of weather readiness and preparedness any time of the year, because it's not out of the question to get these things to happen. And again, find the latest, most up-to-date forecast on our webpage at weather.gov/GUM. This is where we're going to have the most up-to-date forecast for all the islands in our region, as well as tropical cyclone information. Now, based on the climate trends, things can change in a period of several months. We may be issuing an updated outlook to this tropical cyclone outlook in the next couple months if there's any changes in the climate pattern, and that does happen from time to time. So the next slide, this is just our contact information. If you have any questions, feel free to reach out to me by email or to my cell phone. I'm not always at my desk. I happen to have telework. You can also email our operations at that email address and our phone number there. But if you're not part of the Weather Ready Nation, this is one of our big outreach initiatives that we want to reach out to organizations, offices, agencies, businesses, and schools for all things weather readiness, awareness, and preparedness. Send me an email and let me know if you're interested to join the Weather Ready Nation. Eventually, when I can travel down to Micronesia after COVID has subsided, I do look forward to reaching out to the islands more in the Weather Ready Nation program. And for all things preparedness, please do visit the Guam Homeland Security Office of Civil Defense webpage and Facebook page, as well as the CNMI Homeland Security and Emergency Management webpage and Facebook page. And for everyone across Micronesia that has joined us today, these are the links on the right-hand side to our webpage that connect you directly to the WSOs, the Weather Service offices in the region, the Marshall Islands, Pohnpei, and also with responsibility for Koshwai, Chuuk, Yap, and Palau. And again, all of our forecasts, we coordinate those with the WSOs, especially in watch and warning events, because we want to have one concise message from the Weather Forecast Office Guam to the Weather Service offices across Micronesia, and then on to the emergency and disaster coordinators across the region to eliminate confusion or any misinformation that's going on out there. So I'll be looking at the questions. Tiare Eastmond will be presenting next on preparedness in the region. And like I said, please hang back after her presentation because we will go into some overtime accordingly for discussion, question and answer. I know there will be some questions. And so I really want to hear from people across the region because this climate conference is for everyone in our region to be together in this one venue to talk and discuss weather and climate trends and modeling. So again, thank you for joining us. Don't hesitate to call me or send me an email. I look forward to speaking with you and talking with you further. So Leanne, I will hand it over to you and then on to Tiare.
Great, thank you, Landon. Just stand by for just 1 second while I get Tiare's presentation loaded up. All right, you guys should all be seeing Tiare's presentation.
Great, thank you, Lee. Thank you, Landon. I wanted to join this sort of panel of experts to talk a little bit about what do we do in the event of disaster. I think after all of the other panelists, we can be pretty sure that we'll be facing some disasters in the Pacific in the coming years. So I'm Tiare Eastmond, and I'm USAID's humanitarian advisor for the Pacific. I'm based here in Honolulu, but I cover all of the Pacific, aside from CNMI, Guam, and American Samoa for disaster response. So obviously FEMA covers the Guam, CNMI, and American Samoa. Next slide, please. At USAID, our Bureau for Humanitarian Assistance, our mandate is very simple. What we're trying to do is to, first and foremost, save lives, alleviate human suffering, and reduce the impact of the humanitarian crisis. So these are sort of our guiding principles. We do that in a variety of ways, and we try to help the world's most vulnerable people prepare, recover, and transition from crisis to self-reliance. So this is what guides my office and the team that I work with. Next slide. And when do we respond? So globally, USAID is a global office. In the last year, we responded to 66 disasters across the world. Within the East Asia and Pacific region, we've already had 2 disaster responses in this last year. So that would be Tropical Cyclone Yasa in Fiji at the end of December, as well as Tropical Typhoon Surigay that struck Palau just a little bit ago. So globally, we're doing about 66 disaster responses. In the East Asia Pacific region, it's usually something between 7 and 10. We've noticed some of the overall trends in the East Asia Pacific region is that cyclones, earthquakes, tsunamis, drought, these are the things that we're most frequently responding to, which is a little bit different than globally. My office, the most frequent disaster they respond to is complex emergencies. So out here in the Pacific, we're kind of the rapid onset team, and as are the rest of you, I'm sure. We've also noticed trends in our region of national response capacity improving, and we're getting less requests for international assistance. And you'll see how that's part of our criteria for responding to disaster. So next slide. So we have taken steps to prepare for disaster responses in the region. So specifically in the North Pacific, Marshall Islands, Palau, and FSM, we have strategized with our partners, the International Organization for Migration, the Red Crosses, as well as Catholic Relief Services. And so we have pre-positioned supplies in all of the key North Pacific states. These often are in warehouses. Sometimes they're in our favorite type of warehouse in the Pacific, a shipping container that's been converted. And sometimes there's, sort of an extra office space. So with the stocks that are on the ground and our partners that are trained relief experts on the ground, we have buckets, hygiene kits, plastic sheeting, kitchen sets, and COVID-19 specific items these days. So the good news is our stock levels look good across the North Pacific. We also have specialized equipment that we rely on to respond to drought. So we have a fleet of reverse osmosis units that we maintain and continue to buy the consumable parts for those. So outside of the region, USAID also has global warehouses. So Miami and Dubai would be the closest ones to us in the Pacific. And when there's not enough stocks locally, we can mobilize stocks, which we did recently for Palau. We did an airlift of relief supplies from our Miami warehouse. So preparedness wise, you can never be too prepared, or the things that you prepare for may end up not being exactly the right thing, but we've got a good start in the Pacific. Next slide. Okay, yeah, so now that we know that we're prepared, now that we know that disasters are likely imminent, how do we decide to respond? So for USAID, we have these criteria. So all of these criteria have to be met for USAID to engage in a disaster response. So the first one there is really, of the utmost importance, that there has to be evidence of significant unmet humanitarian needs. So, a lot of times we find that, yep, the disaster was severe, but guess what? The host nation and resources on the ground were able to cover the needs. So there's no role for international assistance, and that's a good news story. That's what we want to work towards. The next criteria is that our U.S. humanitarian assistance will save lives, reduce suffering, mitigate the impact. So that's our mandate. That's the kind of assistance that we need to bring to bear. And the third point here, I think, is especially important, is that we need a request from the host government. So unless the affected country requests U.S. government assistance, we will not be deploying teams or providing assistance to local organizations on the ground. So these are core disaster declaration criteria that we look for to mobilize a response. Next slide. And these are our response options. I think most of you are familiar with, USAID. We can deploy a disaster response team. We can deploy a regional advisor. We can get somebody on the ground to assess the needs and help support and coordinate the disaster response for the U.S. government. So we can send people. When we meet the disaster declaration criteria, we often provide immediate $100,000 to an organization on the ground to purchase immediate food, relief supplies very quickly. And we do that within 72 hours. There's the option of dispatching commodities, which I covered. We did that recently from Palau. And then the yellow hat, hard hat there, is that as USAID is the lead federal coordinator for disaster response, we can request other U.S. government agencies to support us. So that could be the Coast Guard, that could be Department of Defense, that could be Department of Energy when we had sort of a nuclear earthquake in Japan with nuclear issues. So we have that capability to bring in other government expertise as and when we do need it. Next slide. Okay, and I just wanted, this is my second to last slide, I just wanted to provide a quick update. So in Palau, the tropical cyclone Surigay, did have a much wider impact than we initially thought. 125 houses destroyed, 4,335 people in damaged homes. So we ended up needing to do 3 airlifts of relief supplies. One of those airlifts came from our USAID Miami warehouse, and the other 2 came from the Red Cross's Kuala Lumpur warehouse and were transported via World Food Program airlift planes. We've also, the Red Cross is working with USAID funds on cash distribution to promote self-recovery. So in addition to providing stuff, affected households are given small cash grants so that they themselves can buy, is it the new window or some tools to help them get on the path to self-recovery as quickly as possible. And then we're also expecting our replenishment of stocks in June from the USAID Miami stockpile. This is coming by sea. what we learned from Palau is that we needed to have more stocks in country, and so these stocks will be part of that sort of expanded pre-positioning effort for us in Palau. And last slide. And that's my email address. That's my contact info. We do a lot of stories on the Pacific on our various social media platforms. So please follow us if you're so inclined. Thanks so much, Landon, for having this opportunity.
Hey, thank you, Tiare, for the presentation, and Leanne for running this program. I'm not sure how things look on your end, Leanne, if you can see people who might have questions that want to discuss. But if we want to go into a discussion format and verbally ask questions, let's do that, Leanne.
Okay. So if you want to ask a live question, you should be able to, there's a little button that looks like a hand. If you hit that and raise your hand, I should be able to unmute you. Or if you have microphone problems, you can always still put them into the question box. So while everyone's getting ready to put their hands up, I can just, I'll ask some of the questions that we have in here that haven't been quite addressed yet. So we do have, let's see.
And if you could, Leanne, put up that that title screen from the second slide from the title screen, so it would have the names and the presentations up there from the beginning of this conference.
Okay, we do have one question
Panelists, bring
here.
yourself on camera.
If 2 to 6 TC formations for the Marianas reflects a normal typhoon season, what would an active or highly active typhoon season look like as far as potential number of formations?
Well, that number could vary. Yeah, that number could vary significantly, and that would be linked closely to the El Nino pattern. Think back to 2015, we had a lot of storms in the region. Fortunately for Guam, we did not take an exact hit, but the number would increase because those storms would develop farther east across eastern Micronesia, the Marshall Islands, and that would put us more under the gun.
So I mean, if you look at the West Pacific, I mean, not specifically for the sub areas defined, I mean, an active year would be 20 to 26 storms. That would be for the entire West Pacific. So even if half of them got Guam, that would double the current forecast.
All right, Mark, I see that you have your hand raised. I have unmuted you, so you should be able to speak now.
Yeah, can you hear me?
Yes, we can.
No,
Mark, are you still? Oh.
I'm gonna say active year.
Sorry,
19. Can you
Mark,
hear
you're
me?
back online now.
I'm online. Can you hear me? No.
I can
Yes,
hear you.
I hear you, Mark.
Oh, okay. Yeah, I was gonna say an active year. 1997, there were 7 super typhoons. Just the count of the super typhoons that threaded between the Mariana Islands, including the last one. They all missed. They went between. Even one between Rhoda and Saipan, that it was Keith, I think, and it went between, and each island was okay until the last one, Paca, in December 97, hit Guam and Rhoda. So that was just the super typhoons, 7 of them in 1 year, threading between the Mariana Islands. As for a really busy year, 1996 had 43 numbered cyclones, including 36 typhoons in the basin. So that's a very active year. And 97 didn't have so many total, but because it was El Nino, many of them are out in the Mariana Islands, and a total of 7 super typhoons at super typhoon intensity went between one or more. Have to have at least 2 to go between them of the Mariana Islands. So whoever asked that question about what's an active year, there's 2 very good examples. 96 for the basin, 43 numbered cyclones, 36 typhoons. 24 typhoons, whatever the number, I have to look it up, but 43 total. And 1997 was very, very active for, and then you got 92, the year Guam got Omar, 5 typhoons passed within 60 nautical miles of Guam. And there were 3 eye passages over Guam. So that's an active year too. For Guam, 3 eye passages and 5 typhoons that came within 60, including those 3 eye passages. So there's your high end or top end kind of scenario. And who knows if it'll happen again. But anyway, I thought I'd throw that in there from a long-term memory perspective.
Yeah, thank you. That was Dr. Mark Lander from here at the University of Guam. He's been part of our weather office family, especially all things tropical weather. He and Chip Guard, also on the call, they're both powerhouses when it comes to tropical cyclones. And so they were integral part to this outlook for the region. And so Chip Guard, you're also on the call, so feel free to chip in if you'd like to. And also I was talking to Dennis Wang from Sea Grant, preparedness across Micronesia. If you want to speak to the FSM homeowners handbook that's in the process for the Federated States of Micronesia.
All right, Dennis, I have unmuted you, so you can take the floor now.
Okay, well, thank you for this conference. It was very useful. And I hope it's gonna. I hope it's gonna be recorded. I'd like to digest more of it. We're in the process of putting a homeowner's handbook to prepare for natural hazards for the Federated States of Micronesia. There's currently one in Hawaii. It's the 4th edition of that book, and it's gone through 10 print runs with 100,000 copies. There's also one for the Marshall Islands that was done in 2016 or 2017. There's also there's also a homeowner's handbook in 10 other states and countries right now. We're in the early stages. We're trying to collect some hazard risk information that we could digest and summarize for the book. Oh, by the way, I just like to backtrack. We're working with Tiare and USAID, our key partner in the book, who helped fund the book, and also National Weather Service. And again, we're in the early stages. We're trying to collect hazard information that we could digest to put in the book. The book will also have a section on emergency supplies and evacuation planning, and also things homeowners can do to prepare their residents to make it more resilient. And a lot of, as soon as COVID, things open up in FSM, we would like to, be visiting with 1 or 2 engineers, and we would like to be go visit some of the islands to get some of our thoughts on vulnerabilities of the houses there and what could be done to strengthen them. That one, of course, that won't happen until FSM opens up. Hopefully, Landon mentioned that he would like to go to FSM also to do some preparedness work with the islands there, and there may be a chance we could collaborate or go roughly at the same time. But that's, if you're more interested, feel free to contact me. And we are looking for key scientific information to put in the book. Yeah.
Thanks, Dennis. If you could just send your email or what contact information you want, I can then blast it out to the chat for everybody. So
Okay.
Now, Bernadette, I see that you have your hand raised. I will unmute you, and you can unmute yourself and ask away, Bernadette.
Okay, I you. Thank you for inviting me to the webinar. So I'm Bernadette. I'm a Palau-based reporter. My question is, at the start of this web, it's mentioned that this was the first region conference. Why is a discussion like this necessary? And also it was mentioned that the typhoon gave that hit Palau in April, it was surprising. So how do we prepare for surprising weather events like that?
Yeah, thank you very much, Bernadette, and I'm glad you could join us today, especially following Sergey. That your article that you wrote for The Guardian was brought to my attention, and so that gave us good perspective on how people are perceiving and seeing things on the ground from islands away from Guam, especially during Sergey. That was a good perspective for us to read through and see how things were felt there in Palau. Your question was breaking up, so I'm going to try to answer it the best as I can. If you recall back to my presentation, the first thing is the communication. When there's a perceived or possible threat for any of the islands in the region, we are communicating that through our forecast discussions, our forecasts, and our social media posts, because that's where you have your instant awareness. Also through the Weather Ready Nation, send me an email link and you'll be getting some contact from me as well regarding our outreach initiative that we want to also communicate all things significant weather threats and preparedness. But the first step is knowing where to find that forecast information, and that's at the WFO Weather Forecast Office here on Guam. We're putting out those products, those bulletins, and discussions, and we talk about the possibilities of tropical threats to any of the islands. And the ones that's becoming more realized, we start putting out more detailed forecast information and preparedness information that goes to the Weather Service offices, and they do the coordination within the local governments there across Micronesia. So it's very much a coordinated effort to get that information out. Now, regarding Sergey, that was a special case because a lot of the indications were hinting at a long duration event, with Sergey passing very slowly through the Western Micronesia region of Palau and Yap. And so we knew there was that concern, but the indications did keep it farther north of Palau and keeping in that general direction. Of course, with a slow-moving, slow-developing system, that's where the forecasts get tricky, and we have to convey that information more clarity to the people under fire with that weather so that they better know what to expect. And so with these developing slow-moving systems, there can be some significant change as far as which course and track this thing's going to take. And when it's developing while moving slowly, that's where you can expect different intensities. One of the rules of thumb that we have at our office is whatever storm you're expecting, plan for the next category of intensity. So if we're looking at a tropical storm that passed over an island, we tell people to go ahead and prepare for a Category 1 typhoon, or if we're looking at a Category 1 typhoon, plan for a Category 2. Plan for that next level of intensity because things can change. And with tropical cyclone forecasting, we can see a lot of variability in tracks, especially within 12 to 36 hours. And so every 6 hours when we put out new forecast information, there will be a little bit of modification of the track and intensity. And so that's one of the unique challenges we have with tropical cyclones, especially when they're developing over an island, because those impacts can vary significantly. And that's where we have to communicate with clarity in a way that people can understand it, but also where people can find it. And so in my presentation where I talk about our webpage, that's where you want to go to find the most up-to-date forecast information. That information from our webpage, from my office, will go to the weather service offices across Micronesia and then on to the disaster coordinators and the emergency managers.
Great, thanks, Landon. So we have another question, another hand raised from Richard. Richard, I'm going to give you the ability to unmute yourself and you can ask your question.
Can you hear me? Hello.
Yes, we can.
Hi, I'm Richard Mova. I'm working at FSM Deckham, working under the project Adaptation Fund project that we are addressing the water security on 6 islands in the FSM, and 2 of them is Nugor and Kapinga. In one of my visits to Nugor and Kapinga, I noticed that you have some equipments on the top, probably measuring precipitation or water rainfall, the amount of rainfall on those islands. And in one of the comments during I think in Matt Rosencrans' presentation, there was a comment that there were missing data collecting on those island stations. I was just wondering if these are the stations that he's referring to, and what are the reasons of missing data, or are there any mitigation measures that are going to be put in place to have those data completed throughout the years? And second question is, those data that are being collected on those islands, are they being referred back to the islands in terms of presenting what are those equipments for, their importance, and the data that actually collected for them to understand what are they collecting for their preparedness and education work for the communities to actually prepare on what's coming in the coming months or years? Thank you.
And I don't know if Brandon Buchan, if you're still on, or Matt, if you could respond to that.
Yeah, so we tried to pull data for all the US API drought monitor stations. There's 23 stations and there's a lot of holes in data there. So unless the data is sent, I mean, honestly, I don't know how all the data gets to the GHCN stuff at NCEI. I don't know how it gets into those files. But I do know on the PIAC call every month, I guess now it's not PIAC anymore, it's PIACSIS or something. There's a different acronym. On that call every month, people are definitely reminded to work with their, to work with either themselves, their office if they're responsible for, or to work with their partners that are responsible for sending in observations, just how important those observations really are. I don't, backfilling the data, I mean, if islands have, if you guys have them and they're somewhere on each one of the islands and you can mail them in, I mean, I would take them.
Hi, this is.
Go ahead.
Hi, this is Brandon Buchan. Can you guys hear me?
Yeah. I mean, I can.
I just wanted to follow up on Richard's question. Kapinga and Nukuoro are very reliable for rainfall and temperature values, and I'm quite certain that the process is all of that data is sent to our office in Pohnpei, and it is transmitted to through the various channels to get into to CPC's data sets and analysis. So I will try to follow up on this as to why it might not be available, but I will say, looking at the data regularly, Kapinga and Nukuoro are very reliable for rainfall and temperature. So thank you for bringing this up, Richard.
So Brandon, just to follow up, this is Mike. So that's obviously that's in the real time we're seeing that, but one of the critical things is when we're trying to develop limits and ranges, we need the historical data. When we were in the process, we needed data back to 1981. I guess technically, since we've now shifted our base period forward 10 years, we only need it back to 1991. So do you know whether those stations have been in existence for that long and whether they've been submitting data regularly since then?
Yeah, I don't have that off the top of my head, but I'll follow up for sure. Yep.
Okay, appreciate that. And really from a lot of this, we were actually getting this data from NCEI. So it doesn't need to come in directly to CPC. You know, we can pick it up through NCEI just as easily.
All right, thank you everybody, and thank you Richard for those questions. I know that Brandon will follow up with you. And now let's see, Chip, I'm going to unmute you and you can ask your questions or state your comments.
Okay. Regarding the rainfall data out there, the islands have been really very good at providing that data. Now that we have the WX coder, you can see the data is getting into the system fairly reliably. What happens is the outer islands report this data a lot of times via HF radio, and it's recorded in the main islands. And we work with the main islands, and at the end of the month, they send us the monthly rainfall data. And we run through a fairly critical quality control of that data. In other words, if it doesn't look like we think it should look, we ask questions and to make sure that the data is complete. And then we have databases that track the monthly data, because it's a monthly data really that's very critical to us in looking at the seasonal forecast. So that data, there's a period of time when I think NCEI started to outsource the accumulation of that data. There used to be late data that was processed, but it seems to me like if the data gets in late now, it's just not processed. It wasn't processed. There's a period in the early 2000s where there's a gap of 5 or 6 years, and that monthly data is available. I'm sure the daily data may be available, but generally what they do is they quality control that data and then send it forward, I think, to a place in Kentucky, but now it's all put into the WX coder. But I'm very confident in the quality of that monthly data. Also, we have inline statements in there, and there are periods when you can use you can make an estimate of the data, and that estimate is certainly better than no data at all. And so we do have this data available. It's been passed on to Brandon. The other thing is about tropical cyclones is that we, you know, when Mark was talking about 7 tropical cyclones in 1997, there actually were 11 super typhoons that passed through the Western Pacific. Looking at Western Pacific information per se may or may not be a good way to evaluate what's happening in Micronesian islands, because the Micronesian islands are very dependent on the status of El Nino, and during El Nino periods we can get a lot of activity, and during La Nina periods we may see very little activity. So it's very important that we look into these into the effects on the Micronesian islands per se. And finally, most of these outer islands are atolls, so they don't have a local effect so much on the rainfall as, say, high mountain islands do. So I'm thinking that if we can get reliable background satellite data, we can get a pretty good estimate using that background data of what the rainfall was on specific, say, atolls. So that's just another comment. So those are my comments concerning the rainfall and the tropical cyclone data.
Great, thank you, Chip. Now, Masood, I see you've had your hand raised for a while, so I'm going to give you the ability to unmute yourself and take it away. All right, Masood, sorry if I'm pronouncing your name incorrectly. Masood Tiare. All right, I see you've unmuted yourself. Unfortunately, it doesn't seem like we can hear you right now. If you'd like to type your question into the question box, I can read it out loud for you. All right, while Masood types his question into the question box, Philip, I'm gonna let you, I will unmute you and you can ask your question.
Hi, can everyone hear me?
Yes.
Okay, yeah, this is Filion Guerrero from the Guam Daily Post. I'm wondering, will emergency operations centers at NWS and civil defense be staffed as normal if a typhoon happens during this public health emergency? I'm not even sure if remote work is advisable because telecommunications outages are expected during these types of events. So I guess, I wonder if we already know the answer of how we're going to respond if a typhoon happens during COVID, or if a tabletop exercise has already kind of played out that scenario, or if another simulation training has been planned to kind of address this.
Yeah, thank you for joining us, Phil. Great to see you here. I don't know if anybody from Guam Homeland Security is still here or the CNMI Homeland Security Office, but I can answer in response to the National Weather Service. We're following closely the protocol given to us by the Department of Commerce and NOAA National Weather Service headquarters. And so we are functioning within our facility as nearly business as normal with, of course, standard protocol. We're still limiting people within our facility to mission essential only. And since most of our staff are vaccinated, we do have that working in our favor. When it comes to typhoons, we will be all hands on deck, still with some protocol in place that we do have to keep at least a little bit of distance from each other. But we have capability. I'm working from home. We do have some capability to work from telework locations. But when it comes to the actual communications, the weather forecasting and stuff, all of that is generally done from the office. So we do have to keep some protocol in place as far as keeping some distance, masked in some senses, but that's how we are on the weather service. I see Jenna Blas is still online. I don't know if you, Jenna, could answer to some of the questions regarding Homeland Security operations. The Guam Homeland Security did just wrap up a tabletop workshop last week for Typhoon Paksu. That's our annual workshop. And they do have some lessons learned, takeaways from their exercise last week. So Jenna, I don't know if you have something to add to that regarding Guam Homeland Security. And then CNMI, if you all have some input as well as to your operations.
So Jenna, you should be able to unmute yourself if you are around. All right, in the meantime, it looks like Masood did, he was able to put his question into our question box. I think our expert might be gone on this. We can always forward the question on to him, but maybe Matt or Mike or Landon or Brandon can answer the question. So he asked, considering sea level rise is not constant, what are the best prediction models indicate the rate of rise?
Yeah, I'm not going to volunteer to answer that question, but I will say this, that with every steady increase in sea levels, that does make low-lying and coastal areas across the islands, especially the low-lying atolls and islands, more susceptible to water and surge-related issues when it comes to high surf events, large wave events, and that can be with tropical cyclones or with other sources. So with every inch of sea level rise, that does make a coastal location more vulnerable to problems. So we do have to keep that in mind. And so these problems do exist without the influence of sea level rise. But as far as the modeling, I'm not going to volunteer to answer that. I think we have better climatology folks and modelers that can answer that in more detail.
Yeah, I'm not sure much on the aspect in terms of climate change. Certainly there's relationships between sea level and El Nino and La Nina. As sea level rises, just in general, they become more problematic. You know, I could be wrong. I think sea level rise is probably higher with La Nina over in the West Pacific. Not positive on that. That's my gut thought on that. You know, in terms of, again, the gradual, you know, there's a lot of modeling that goes into that. And that is a product, I think, that I was talking about, something that we're looking at down the road a few years in issuing, you know, maybe some type of a seasonal sea level rise outlook for that region.
Brandon here, just to follow up real quickly. The observations show it's about 3 millimeters per year increase in sea level rise on average. But as the previous Landon mentioned and Mike, large wave events, and then the La Nina and El Nino, higher sea levels across the Western Pacific during La Nina, and lower during El Nino is a big player as well, with over nearly a foot of sea level difference between a strong El Nino and a La Nina cycle.
Great, thank you, everybody. Looks like Chip has his hand raised again. I believe, Chip, you should still have the ability to unmute yourself.
Just one thing on the prediction of these, the prediction of sea level rise. What they do in these climate models is they have what they call representative concentration pathways. And what they do is they put in low concentrations, medium concentrations, and high concentrations of CO2 into these climate models, and those will in turn generate rates of temperature rise, which can be related to the expansion of the ocean and sea level rise. So the question is, which one of those is the most accurate? Would it be the low concentration, the medium concentration, or the high concentration? So what they look at is maybe the 1 foot is representative of low concentrations, 1 foot by the end of the century, 3 feet by the end of the century, maybe the effects of high concentration. So you see, they give you a range, but nobody really knows exactly 30 years from now, or 50 years from now, or 70 years from now, what the actual concentrations will be. So that's the way they do the modeling for the sea level rise. I hope that clarifies it a little bit.
Great, thank you, Chip, for that clarification and extra information. Mark, I also saw your hand go up and down. I believe you still have the ability to unmute yourself if you'd like to go ahead now.
Yeah, I just unmuted. Did it work?
Yes, it did.
Okay. Yeah, the question earlier was about sea level rise, and I think a point needs to be made. There's two components. One is a huge sea level rise up and down from the trade wind forcing. That's why there's a difference between La Nina and El Nino. The trade winds can push the sea level. The difference of 2 feet, a foot higher in La Nina and a foot lower in El Nino. If you take the current high sea levels now in the last decade, about 80% of it's due to trade wind forcing. It's not climate change, unless trade wind forcing itself is climate change. There's a very slow background rise that is the climate change piece, but that's not why our sea levels are so high right now. The very high sea levels the last 2 decades is because the trade winds got stronger and set it up in a mostly non-La Nina-like pattern and made them very high. So there's really two components to look at. The long-term one, whether it's 2 centimeters per decade or 1 or 3, as Chip was talking, these different scenarios, that's the long-range outlook. That's a completely different component than our huge up and down between La Nina and El Nino. And that entire forcing of La Nina and El Nino, if you want to get a good outlook on that, just not looking ahead for the climate change, 50 years, 100 years, but just next year, if you can get a handle on trade winds, you'll get the sea level. And if it's El Nino, it'll drop 2 feet down lower than it is now. And if it's La Nina and strong, it'll come right back up. Those big changes are entirely trade wind forcing. And it's built in about a 2-month delay. If the trade winds suddenly collapse today, the sea level would fall in about 2 months. It would just kind of fall away if the whole Pacific trade wind system just stopped. So it has a 2-month lag, and the whole Pacific trade wind system is pushing the sea level up and down here a substantial amount, way more than the climate change part yet. Climate change, even all the climate change so far, is only about 20%. If you take today's sea level, it's 20 centimeters higher than average. 20% of that is due to climate change, and 80% of that is due to the trade wind forcing. So that's I think that was what the previous question was about, forecasting sea level, and it wasn't. I got the feeling it wasn't entirely about the climate change, but more shorter term. How do you go about making these forecasts of these big sea level changes? Okay, that's it.
Thank you, Mark. I don't see anybody else's hand raised. We do have a couple more questions in the question box. I've got one over here from Dennis. He wants to know that, so in 2016, there was a record number of tropical cyclones in the Central Pacific, supposedly affiliated with a super El Nino. Is high frequency in the Central Pacific correlated with high frequency in the Western Pacific? And are super El Ninos believed to be more likely?
Am I on?
Yes.
Go ahead, Mark.
Yeah, my little buttons are way out. I don't know why they're not with the window. They're up on the far corner of my theater level screen there. But anyway, the 2016 and then 2018. When did that super hurricane threaten Oahu? Was that 2018? I forget the name of it.
Lane was in 2018, but in 2016 there was no direct impacts to Hawaii in 2016, but there were the 16 tropical cyclones in the basin.
Yeah, the number of typhoons or tropical cyclones in the Central Pacific is highly correlated with El Nino. You get a lot during El Nino and when it's La Nina. Now you get a lot coming from Mexico, even the ones that form off of Mexico and drift westward. So you have two sources in Hawaii. You get Central Pacific homegrown and the ones moving from Mexico in. It's El Nino related, and also, whether true or not, the climate change projections, it's one of the few places in the world where it shows an increase. This is probably little known. When they do climate change modeling of future typhoon distributions, the Western Pacific drops off by up to 50%. We get cut in half. Now, Hawaii region, Central Pacific and Eastern Pacific, it's one of the very few, everywhere else on the globe goes down, but they're one of the few places that model simulation says there's going to be more. And you get more from two sources, both the Mexican ones that form and drift into their area and homegrown in the Central Pacific. It's for whatever reason, the climate change. And people it's kind of unclear. Is the climate change increase there because of a change to El Nino? And some people say that's true, and other people say no, it's the global warming signal. It changes the climate such that the Central Pacific gets more, not because it changes El Nino, but because it changes the SST pattern or some part of the general circulation that the Central Pacific and the Eastern Pacific, the Hawaiian region gets more. If you look at the map, there's only a red and yellow increase from westward from Mexico and into Hawaii, and everywhere else is green and blue for a reduction. That's probably little known. In fact, Western Pacific, we take the prize. Guam is in an area that the climate simulation has cut them in half. So anyway, but the answer to the question about 2016, it wasn't, there were a lot of weak ones, a lot of out near the date line crossing over. It wasn't El Nino and it wasn't La Nina. It was just its own peculiar year. So there's no attributable cause to having a lot of Hawaiian named storms in the Central Pacific in 2016. But it is a global warming projection that should be made aware of, as ours too. So anyway, hopefully that takes care of that question.
Great, thanks, Mark. Thanks for that great insight from some of those global warming projections. I do have another climate question. This one's about heat. So for the climate services, one of the major concerns that we hear from the communities are about the increase in heat. What is the trends and forecast on this?
Well, I got some insight on that. It depends on what record you look at. If you look at Andersen Air Force Base, there's a complicated temperature signal. It dropped a little bit through the 50s and 60s, warmed rapidly through the 70s, 80s into about 1998. 1998 was the warmest year. And from then on, it stabilized or got even lower. So it's kind of an S shape. It's not this monotonic, it's not just getting warmer, warmer, warmer. There's a very complex pattern to it. And a lot of it has to do with the way they take the data and archive it. It's not a clear answer. One of the best answers, and I direct people to check this out, an organization called Berkeley Earth, berkeleyearth.org. They got a bunch of private sector money, and they got together to answer the question. Basically, they got together to end the debate on, did global warming stop in 1998? You know, that meme that's out there, that global warming stopped and it stabilized. They wanted to just get to the nut of it, and they took all of the stations and analyzed everything, and they came up with an answer. And they got every station on their website. In Guam, every single station is on there with the temperature, long historical temperature record. They even have Guam temperatures from the 1920s. I don't know where they got that, but they have it all. And what they did was they took all the raw data and they did statistical breakpoint analysis. They did a very complex analysis mathematically and adjusted for all the breakpoints and came up with a regional expectation. Their regional expectation is a very, very good, in fact, it's all across Micronesia. Every station is warped differently. When they take all these breakpoints and adjust Yap up and down and Guam up and down and Andersen up and down, they're all different, but they all snap to a nice regional expectation. So if you want to see the temperature, berkeleyearth.org is a very good place to go. And I got the same answer they did by doing something very different. I adjusted for the known errors in the Andersen Air Force Base temperature record, rounding up instead of down, rounding off, or converting Fahrenheit to Celsius. I actually accounted for the errors and came up with the same temperature trend that Berkeley Earth came up doing just a mathematical analysis. So that becomes a very reliable, if you want to know now that's not a projection, that's just what it has been from the past to now. Berkeley Earth is probably the place to go. The extent, the picture that should be put up, what is our temperature doing? Get the regional expectation value from the Berkeley Earth and post that. It gets the same answer I get by accounting for the error, and they did it mathematically. And that website, I found it very useful, and it has all the data, all of it. The data I didn't even know existed. They were very, very comprehensive. It has Guam temperatures in the 1920s and 30s. I don't know where they got it. Chip might know, but I didn't know we had temperature data back there. But they got it all. So if anybody's interested in that temperature question, that's a place to go. Hopefully that answers some question.
I think that's right, Mark. I think Chip would know.
That's
He's
probably
a legendary figure when it comes to weather and climate.
That's
Chip,
probably,
go ahead and.
Yeah, that data is probably from the Navy CNMI data, which CNMI is down where Naval Station is now. It's where the old Pan Am Clippers used to land.
Okay.
And there's data there. I know I'm very familiar with the rainfall data from about 1905 all the way up to 1940.
Yeah, the Berkeley Earth had temperature, and it was way off. They had to snap it way down for the regional expectation. It must not be the same station because I had to adjust it by 1.5 degrees. But the variation, the El Ninos and everything else shows up real nice. I was surprised there was such a long record. It's probably useless for trends because what Berkeley Earth did was simply adjusted it to the regional expectation, which is kind of cheating. But whatever.
All right, thanks, Mark and Chip. And I guess we'll wrap up this first climate conference with my office here. I hope this was a beneficial conference for everybody here that joined us today. And I would like to consider making this an annual event to really bring us all across the region together in one venue to talk all things related to our region. So there will be a survey once you close out of the webinar. I appreciate your responses to the survey. The feedback will help us build this program and how we can better reach out and serve the people across our region. So thank you for your time and effort. Thank you for Leanne for running this webinar for us, and everyone for joining us from across the Pacific and from the States. So contact me, send me an email or a phone call if you have any questions, and we will link back up that way. So thank you all for joining us today, and have a great Wednesday, Thursday.
Amen.
Goodbye, everyone.
Yeah, how do you sign out? I don't have the sign out button here. I guess I just exit out.
Exit off.
Have a good weekend.
And just as one last reminder, if you do want all of the PowerPoints you saw today from the little handouts tab that you see probably on the bottom, you should be able to get all 5 of those presentation PDF links.
Okay. Thank you. Good job.